Friends, let us talk about when to make a second order construct in structural equation modeling, whether you are doing covariance based structural equation modeling in AMOS software or you are doing PLS, SEM or variance based structural equation modeling in smartpls or other concerned softwares. Now, there's a tendency in the researchers that they deliberately make second order construct without considering that whether it has to be made or not. So there are two major criteria to make a second order construct. Whether you want to make a reflective or a formative, both can be made. Now, one is that there has to be a high amount of correlation between your predictive variables. That means if you encounter high multicollinearity between the predictor variables, I am here talking about the predictor latent variables, unobserved variables, not the indicators. So between those latent variables, if they exhibit high amount of multicollinearity, in that case you can make a second order construct if they represent a single common latent variable. That is what is the concept of second order construct, right? They should be the part of that second order construct. In case they are different, then they should not be having multicollinearity issues. So if they are exhibiting this kind of behavior, that means they must be gelled together to make a second order construct. Now, what happens in case you don't make a second order construct? In that case, the structural equation modeling algorithm fails to capture the uniqueness of these latent variables. How is it possible? So, how does it fail? When there is high amount of correlation between the predictor variables, your standard error rises up. So when standard error rises up, the z statistic, the statistical significance gets lowered. How do you calculate a z statistic? The formula is you divide the estimate by the standard error. So standard error rises when there is high amount of multicollinearity between the predictor variables, which leads to decrease or suppression in the value of statistical significance, which is the z value. Now, when z value decreases, now we come to empirical rule of normal distribution. So, empirical rule of normal distribution says a normal bell-shaped curve ranges in from minus infinite to plus infinite, right? It has a mean of 0 and standard deviation of 1. 99.7% of the points are captured within minus 3 to plus 3 standard deviations. We already know that. So when the z value decreases, it comes somewhere in the middle of this normally distributed curve. So when it comes in the middle, it is situated within the middle, say z value decreases to 0.25. So that is nearer to 0, right? So when it comes to 0.25, there is a large amount of shaded area, gray area, within which the probability of having the results by chance, that is you test through probability testing, p-value, that shaded area becomes quite significant, quite large. So when the shaded area, which extends from the z value up to the infinite limit of the normally distribution curve, that shaded area becomes large, because now z value is situated in the center of the normal distribution curve, close to the center of the normal distribution curve. So when this gray area, the shaded area of probability increases, in that case what happens? It leads to type 2 error. What is type 2 error? When p-value rises, so the p-value rises, okay, because you have a greater area. So when the p-value rises, you fail to reject the null hypothesis, right? You fail to reject the null hypothesis, and in that case, in case it was a false null hypothesis which should be rejected, you fail to reject it. This is known as type 2 error. So it leads to type 2 error if you don't make a second order construct. Now, coming over to the second reason, first primary reason is you should check in for multicollinearity between the predictor variables and then decide upon making a second order construct which is formed or which is a reflection of that latent variable. Now, the second point is that it should have a strong theoretical backing, strong theoretical support, that whether they are converging together, they are forming the second order construct, or they are the reflections of that second order latent variable. So if you have a theoretical backing, then you can support your statistical results, the multicollinearity fundamental, and backed up by the theoretical backing, you can construct your second order construct and analyze it conveniently in your structural equation modeling. Unless you are able to find high amount of correlation, actually it is a remedy. It is a remedy to deal with high multicollinearity prevailing between your predictor variables. So I hope you understood the phenomena and when to use, how to make second order constructs easily in structural equation modeling, so that you don't make a mistake next time.